I've got a new toy here in the man cave. Actually, more of a manhole. It's too small to be a man cave. But anyway, I was going to get a signal generator. I can do signal generation with the Regal 815 here by setting span to 0 and setting a frequency here, and that'll give me a carrier that I can go from 0 to -20 with. But of course I can't convert that to some other frequency and look on the spectrum analyzer because it's a tracking generator that I'm using for that purpose. So I wanted to get a signal generator. I looked at some of the used ones. The 8640B looked like a very good candidate, but it's huge. It would hang over the edge of this desk that I've got here. And it's very heavy, and it's about, so high. It's about as high as this is set up like this. Does have internal modulation and can go up to 1,000 megs. But I saw this and I said, well, let's give that a shot because it'll still give me carriers. It'll give me modulated output as well. And it does have this RF detector over here, which can go up to plus 10 dBm. And the output here is 35 megs to 4.4 gigahertz. So it covers a lot more frequencies than the 8640B would. So anyway, I got this thing for about the price of a used 8640, and I'm just checking it out to see what it does now. All right, let's see what it's got. It's got an auxiliary input for plus and minus 5 volts or AC, whichever you use. I'm told that it can do square waves. It can also do sine waves, but with sine waves, it probably only will give you plus or minus maybe 3 kilohertz. 10 meg reference output. There's a 10 meg reference input here as well. And if you're using that from an external high stability source, then you can set it up to come out here to go to the next instrument, say the Rigel here, or some other instrument that uses 10 megahertz for the reference. The USB data line here, that's this port right here. And if I want to just run this thing in a car or off a battery, I can use a USB cable in this battery port here. Same thing, but with no computer control. So an FM input here for modulation. So it has some good features there. The detector out input here, it will measure signals, either the signal from this generator or other signals that you might be wanting to check, up to plus 10 dBm at least. Has a trigger output for use either with like a spectrum analyzer or a scope, something like that. An LED to tell you the RF is on, an LED to tell you that the power is on. And then it's got a button for RF on and off for manual control, and a control button here for doing user settable features. And so that's what we're about to check. So I'll lay it down, put it in front of the spectrum analyzer here, and we'll get started to see exactly what this thing will do. I'll get this up so we can see the analyzer. I'm going to start up the TP-Link program, and what we will get is a screen that will give us various functions available. First screen you get is this link page, and it's assuming you haven't connected the unit yet. It says COM4 is available, so we'll hit link and see what happens. Searching for the unit, finds the unit, synchronizes with the unit. And it tells you that it's a TPI-1001-B USB virtual port COM4. Gives you the model number and gives you the serial number and the hardware version. It gives you the firmware version and says that it's up to date in this case. If it wasn't, I could click on upgrade and it would allow me to upgrade that to the latest version. So the other thing I can do on this page is I can set this over in this corner, that corner, in the center, which is where I have it now, in this corner or that corner of the screen to get it out of the way of any other program I might be using at the time. I click the generator tab and it comes up that I've previously put 1296 megahertz here, and it says type in a frequency and hit enter. So let's make this maybe 50.125 megahertz, which is a common call-in frequency on the 6-meter amateur band. Now you notice I have 315 here, 433, 915, which are common low-power device frequencies. I'm not going to be using those, although when I was working, I did use those a lot. And then it's got some other microwave type frequencies here, high UHF and microwave. But if I want to put this 50.125 in this box, all I have to do is hold the button down for 2 seconds and it changes red, and now I got 50.125. Let's say I want to change this to 144.200, which is the 2-meter amateur band calling frequency. I could hold down button 2 here, and there we go, 144.200. Now let's make this box over here, we'll make it 432.100. And I can put that in this box. I can come over here and go to the next amateur band, which would be 902.1, I believe, for the calling frequency. Hold this in for 2 seconds. Next amateur band is where I was earlier, 1296.1. And let's say we want let's see, 2450.1, I believe, but I'm not sure about that one, but we're going to put that in there anyway. Hold this down 2 seconds and it changes. So I now have 50 megs, 6 meters, 144, which is 2 meters, 432, which is 70 centimeters. Let's change that. I forgot 222. I was wondering why I got to 2450. Okay, so then we'll make this 432. Make this 902.1. And we'll make this 1296.1. Okay, so there I have the amateur bands calling frequencies for sideband, this is, or CW. Might put it on calling channels for FM, whatever. Now, if I wanted to have this thing come up in the same fashion each time, what I would do is I would come over here to System and save output state as parameter default and parameter as default. So if I click on that box, now it's saved all that. So if I was to close this, then reopen it, takes a bit of time to open. Again, link. Pretty quick on the link. Go back to generator. I still have the frequencies I put in these boxes here. So that's a very handy feature if you use this as a particular signal generator. All right, over here I have 0 dBm, which is the output level that would be there if I turn the RF on over here. I could set this to 10 dB, and it'd step up to plus 10, 0, minus 10, minus 20, minus 30, minus 40, minus 50, minus 60, minus 70, minus 80, minus 90. So there's 100 dB of range in this unit. So you could go from 0 dBm to minus 100 by putting a 10 dB pad on the box over here. Or say a 50 dB pad, you could go from minus 40 to well over 100 dB, minus 100 dBm. There's also boxes down here, so I can make it plus 10, 0, minus 20, minus 30, 40, and 60 like he's done here. Or I could put values in here and make this say 0, minus 10, minus 20, minus 30, minus 40, minus 50, whatever that I want to do. So let's see what we've got here. We'll click on 50.125 and turn the RF on. Now you'll notice we don't seem to see anything here in this because, as you may recall, we were at minus 90 dBm and our noise level here is at minus 50. So let's put this at minus, I'll put the thing at minus 50 dBm here. And you can just see the thing peeking out of the noise here at minus 50. So we'll go up maybe to minus 20 dBm, get us well out of the noise. And 10, there's plus 10. So plus 10 is showing up at a peak of 7.90, which is off quite a little bit, of course. But before we get to why that's the case, notice every other harmonic here, and there's a lot of them, is down. This is at plus 10, well, plus 7, plus 8, down to minus 38, so that's 48, 50 dB or so. And every other one is higher, so the even harmonics are down here, and the odd harmonics are up here, which those of you who know what that represents, it's a square wave, because that's what this box puts out, is a square wave. So if you were going to use this as a local oscillator or something, you would probably have to use some kind of filtering on it. If you want to use it as a signal generator, you might put a low-pass filter to get rid of all those harmonics. But actually for a receiver, the harmonics probably don't matter to you for most things you'd be using this for. But anyway, let's do one more thing here. Let's put the marker in the center frequency here. All right, now you've noticed a couple of things here. One is that this is set up to automatically set the bandwidth to something reasonable. So I've gotten a little better signal to noise ratio here, and it's put the 50 megs in the center here, and this has gone up just a little bit. But let's also make the span less. We're now at 100 megahertz span. So let's make that 10 megahertz. Okay, get the peak to the top again. 8.11 dBm, okay. Now the other thing is, let's make this continuous peak, so it's going to give us the peak all the time. let's go from 10 megahertz to say 1 megahertz. Span 1 megahertz. All right. Okay, now we're still getting, let's hit peak again here so we read that. 8.12, so that seems to be what the actual level is, which means there's a discrepancy between what this thing thinks it's putting out and what this thing thinks it's putting out of about 2 dB, a little less than 2. Not surprising. This has not been calibrated by me, and I haven't calibrated this recently, so I could be 2 dB off easily. Now, frequency-wise, it says it's 50.128, so that's off, but I've also got a rounded situation here, so it may not be getting the best accuracy. So we'll make that receive bandwidth, 3 kilohertz, let's say. All right. Let's also put this back in the center frequency. All right. And let's also, well, let's go all the way here with this. Let's put this bandwidth at 100 hertz. Now that's taking a long time to sweep because I'm sweeping over a megahertz of bandwidth. See, we just finished sweeping here. So let's speed that up by making this span 200 kilohertz instead. Now there's a method to my madness here. I want to show you the phase noise capability of this particular signal generator we have here, which is pretty good. All right, so let's go marker center frequency again. Moved it over. So it's saying it's 3 dB off. Frequency-wise, it's saying it's right on. So that's good. And the phase noise at 10 kilohertz away here looks like it's in the 55 dB area. And at 100 kilohertz down or up, it seems to be in the 60 dB area. However, I'd say this is probably this generator, not the this spectrum analyzer, excuse me, not this generator, because I've tested before with this spectrum analyzer, and that's about what I usually get. So the likelihood is this meets its phase noise spec. And I got a cat in the middle of my picture. I've gone back to TP-Link, and I've got 1296.1 here. I've set this thing up for the center frequency of 1296. I've got the span still set at 200 kilohertz. And we'll see what happens when I turn it on. Should show up right in the middle of that. So I'll turn RF on. And voila. There we are. Very close. We'll let it continue the sweep through. Let it go through one more time here so we get the entire sweep. And I'll hit peak. And so at that frequency, looks to me like we're at 9 dBm. I just freshly calibrated this unit Haven't done anything with this. It's the calibration it came with. So we're about a dB off, but that's okay. I'm not expecting anything much better than that. Between this instrument and this instrument, these are not $10,000 or $20,000 instruments after all. So there we go, and you see our noise is about the same here. It's down around 50 here, and it's actually a little higher than it was before. So not quite as good at this frequency, but still reasonable. So after getting rid of the cat, I was able to set this up, and we can take a look at what the result is here. I can't go much higher because this only goes up to 1500 megs. But I would presume that we have similar performance up to 4.4 gigs. It'll get a little noisier the higher we go, I would imagine, because of the synthesizer, but still not bad. I'm going to do other things with this. As I say, there's other features of this thing that we haven't covered. Haven't covered the RF detector yet. We haven't covered the FM input. I haven't I do have an external high accuracy 10 megahertz reference that I could plug into this thing to see what it does. Haven't played with the auxiliary input, and so we'll get back to those things. This also can scan between one frequency and another frequency. It can do a bunch of things I haven't done in this particular video, just from the time standpoint. So it's a TPI synthesizer, model TPI-1001-B, and you can go online and search and find this thing. I think it's going to be a good addition to my shack. It isn't as good as an 8641B, 40B generator for many things, but it does have a higher range here, up to 4.4 gigs, as I've mentioned. And I think it will do for the kinds of things I do here in the ham shack.